Alright, let's look at these comparable infinite series. These are surprisingly quite useful, so I'm going to make a video on an example that uses this result. Alright, so let's say you have a non-negative decreasing sequence, A1, A2, A3, and so on. Then summation n goes from 1 to infinity of an, and summation k goes from 0 to infinity of 2 to the k times a sub 2 to the k, converge or diverge together. Right? So let's try to prove that. So here's the notation I'm going to use for partial sum. So I'm going to use S sub capital N for the first series, and I'm going to use T sub capital N for the second series. Right? So let's look at the first, T sub capital N. So I'm going to just write down all these terms here. Right, so you can see that you start with A1, and then you're going to have 2A2, you're going to have 4A4s, and then you're going to have 8A8s, and so on. And the last one is you're going to have 2 to the capital N terms of A sub 2 to the N. Right? And then I'm going to write down the partial sum S sub 2 to the capital N, which looks like this. So you're going to start with A1, A2, A3, and so on. The very last term is A sub 2 to the capital N. Right? And the third one is simply the 1/2 of the first partial sum. So T sub capital N over 2. So you're going to start with A1 over 2. Then instead of having 2 A2s, we're going to have 1 A2. And you're going to have 2 A4s. You're going to have 4 8/8ths, and so on. Right? So we have that. So I lined them up so that we can compare each term very easily. All right, so let's look at the first term here. All right, you can see that as you go down, it's either the same or gets smaller. Right? A1 is same as A1, but A1 over 2 is smaller. Right? If you look at the next term, they're all the same, so no difference. And next one, you can see that you have, as you go down, you're going to have a higher index, which means that the term is going to be smaller. So as you go down, it's getting smaller. And this is exactly the same, right? So here it gets smaller. And then here it's getting smaller. And here, as you go down, it's getting smaller. Here it's exactly the same. And then all the way to last one is exactly the same. But the first partial sum has more terms, so it's obviously it's going to be larger. So we have this inequality. So we have T sub capital N over 2 is the smallest one, and S sub 2 to the capital N is the middle one, and then T sub capital N is the largest partial sum. Right? So once we have those two inequalities, it's easy to make a comparison between series. Right? Let's say the first series converges to S. Right? So which means that the partial sum S sub 2 to the N is going to converge to the same finite number S. And since the T sub N over 2 is even smaller, so we know that the T sub N, capital N over 2, converges to some finite number, let's say T over 2, which means that T sub capital N is going to converge to T. Then we know that the second series is going to converge to T, right? Because it's the limit of the partial sum. All right, so we know that once the first series converges, then we know that the second series automatically converges. All right? What if the first series diverges? Then we know that the partial sum S sub 2 to the N is going to diverge to infinity. Right? Which means that since the T sub capital N is even larger, so it's going to diverge to infinity, which means that the second series is going to diverge. Right? So therefore, these two infinite series either converge together or diverge together. All right? That's it. I hope that this was clear.